and if you have any doubt, if you have any problem, you can ask me at that time. Okay, fine.
Okay, sir.
Okay. So Nawal, hello Nawal.
Hello, sir.
Oh, okay. Mm. So am I audible to you, Nawal?
Yes, sir.
Okay, and if you have any problem, then you can tell me. Okay.
Okay, sir.
So now I am starting. Okay. So today we will study the value of electric potential due to an electric dipole. Okay.
Okay, sir.
So firstly, I am telling you what is electric dipole. Have you remembered, Nawal, what is electric dipole? Matthew? Hello. Okay. So I am telling you the electric dipole.
It's two charges, two opposite charges separated by a
Yeah,
distance d.
yeah, good, good. So this is a charge. This is a charge, and this is a negative charge, and this is a positive charge. And this is the distance. This is the center of this distance. So basically, an electric dipole is system of two charges separated by a distance. Okay, system of two charges separated by a distance. This is the center of this distance. Uh, this is a point charge. Okay, this is a point charge. So I am telling you the electric dipole. So just to get you remember, we will use the concept of electric dipole in the earlier in the derivation. Okay. So
Okay.
due to this dipole, there is a term uh, known as dipole moment. Dipole moment. This is an electric dipole, and this is the dipole moment. The value of dipole moment due to this electric dipole. Again, I am repeating the value of dipole moment due to this electric dipole is given as the magnitude of any of the charge, the magnitude of any of the charge, and the distance between them. What is the distance between them? Anyone?
2a.
Very good. 2a. So this is the dipole moment. Okay. Have you understood?
Yes, sir.
Fine. So this is the electric dipole. Please remember this formula of dipole moment because we are going to use it. Okay. So one thing more I want to tell you. Suppose this is a charge Q. This is a point charge. Okay. What is point charge? Point charge is very small charge. Okay. Very small charge. The size of that charge is very small. Okay. As compared to the distance. Suppose this is a point P, and due to this charge, this is a point charge, and due to this charge, suppose this is a distance R. The distance between the point P and this charge is R. Okay. So this distance is larger very much larger than the diameter of this charge. So we call it point charge. So this is the concept of point charge. So basically, I am not going to tell you the details of point charge, but here we will calculate the value of potential at point P. What is the formula? If you have remembered, what is the formula? If we want to calculate the potential at point P due to this point charge, can you tell me? This is the formula. Okay, this is the formula. So basically, we are studying the physics, and this is physics, and physics is a study of nature's phenomena. So we are studying about the nature. Okay. Hello.
Yes,
Yes,
sir.
sir.
Listen.
Okay. If you have any problem, you can ask me anytime. So I am writing potential V like KQ divided by R, where K is equal to 1 upon 4 pi epsilon. Okay. Can I write this? Can I write potential like this?
Yes, sir.
The more you will interact with me, the more you will learn. Okay. This is the thing. So these are the two things. Please go through it once, and we are going to use this thing in the derivation that we are going to do next. Okay. So what is an electric dipole and what is a dipole moment? Dipole moment is any of, you can take any of charge. You can take minus charge or you can take plus charge. The magnitude. What is the meaning of magnitude? Magnitude is we without any sign. We put the magnitude without any sign, and this is the distance between two charges. Okay, this is the dipole moment and this is the potential. So these two things we will use in the derivation. So now we will move to our topic, that is, if you want to note that, you can note it. Okay, do you want to note? Anyone?
I already noted it, sir.
Hello, what are you saying?
Yes, sir. No.
Okay, if you want to note, then you can note it. I can do it. Okay, so please tell me you have completed the
Noted
note.
it, sir.
Noted, sir. Yeah.
Okay, okay, very good. Hmm. If you have any problem, any doubt, you can ask me, because we are studying the physics, and physics, in physics we use mathematics also and some uh, analytical thinking. So if you have any small doubt or some big doubt, you can ask me anything. Okay, don't hesitate. So we will move forward. So now electric potential. Potential due to an electric dipole. Okay, I don't know what has happened. Sorry for that. Give me a minute. Hmm. Now it's okay. This is our topic. Okay. We will calculate the electric potential due to an electric dipole. Okay.
Okay.
So as we know what is electric dipole, I have told you earlier. It is a system of two charges separated by some distance. System of two charges. So this is suppose this is minus q charge. Sorry for that. Now it's okay. So suppose this is minus q charge and this is a plus q charge. Okay. And this charge and this is a center as I have told you earlier, and this distance is a and this distance is a. So basically this is a dipole. Okay, this is a dipole, and due to this dipole we have to calculate the electric potential. Okay, so suppose if anyone says we can calculate the electric potential on this line also, we can calculate the electric potential on this line also, in this direction we can calculate electric field due to this dipole in any direction, but I am taking a point P here. I am calculating the dipole at this point, so that in the question you feel is you if you will solve the question, then according to this formula that we will get due to this derivation, it is easy. So this is a point, this is a general point. Okay, this is a point P I am taking, and this point P makes an angle theta with this. Okay, low.
Yes, sir.
Yes, sir.
Any problem?
No, sir.
Okay, very good, very good. So this and this is the distance r between this point P and this center O. Okay, this is the distance is r between the center of the dipole and the point P. What is this point P? This is the point where we have to calculate the potential, and potential is represented by V, and I am writing it Vp. So Vp means potential at point P. Okay. So you can notice one thing, we can draw a line like this. Actually, this is not looking like a horizontal line. I'm making it again. So like this is like the actually this is a horizontal line. Okay, it is not possible to draw the horizontal line exactly, but it is a horizontal line, you can imagine. Okay, and I am also drawing a line from this point to this. Okay, hello.
Yes, sir.
So the distance actually we are drawing the straight line in between the this is the between the charge Q and the point P. Okay, and we are drawing a straight line between the point P and where the charge Q is placed. Actually, this charge Q is placed here. Okay, at point A. I have made this charge large so that you can see this charge easily. So basically, the position of this charge is at A and at B. Actually, this is a point charge, so the charge will be at A or will be at point B. So this distance I am taking as R2. Okay, and this distance I am taking R1. Okay,
Okay, sir.
fine. There is nothing complex in this. You will understand it simply if you follow. So we want to calculate the potential at point P. So due to this charge, due to this charge, what is the potential at point P? What is the potential at point P? This charge Q is placed at a distance R2 from point P. So we have a formula of potential. I have told you K Q. Q is the charge.
by R2.
Very good, very good. And this is R. So we can apply here potential due to charge at A. I am representing VA as potential due to charge at A. That will be equal to K into Q. This will be minus sign. This charge is of negative charge. Okay. So this will be R2. So what is the result? Minus KQ divided by R. Fine. So now again we will calculate the potential due to the positive charge. Okay, we will calculate the potential due to the positive charge. This is the positive charge, and we will calculate the potential. So what is the meaning of VB, Matthew?
Potential at that B.
Very good, very good. Nawal, hello.
Yes, sir.
Do you have any problem till here?
No.
Oh, fine, very good. So now I am calculating the potential at point P due to this positive charge which is placed at a distance R1. Okay. So how can we calculate? K Q divided by R1. Okay, fine. Okay.
Yes.
So now now total potential at point, if we want to calculate the total potential at point P, so what we will do? We will add the potential. We will add the potential because potential is a scalar quantity. Okay, because
Yes.
uh, we will add them algebraically. Algebraically means without considering any direction. Okay, simply we will add the values. So what is the value? This is VA plus VB, and this will be equal to, what is the value of VA? VA is minus KQ divided by R. This is not R square. Okay, this is R suffix 2. R suffix 2 means 1 is here. Okay, like 2 is here, so R suffix 2. So this is R2 plus what? Now we will put here V value of VB, KQ divided by R1. Now you can see from here KQ and KQ is common in both the terms. KQ and KQ is common in both these terms. Okay, so we
Yes.
can take KQ common, and we will get minus 1 upon R2 minus 1, sorry, plus 1 upon R. Fine. So,
Yes.
okay. So I can write it like 1 upon R1 minus 1 upon R2. Is there any problem?
Yes.
It's fine now. So basically, now we have KQ 1 upon R1 minus 1 upon R. Okay, this is the equation. So you can note it down. Please note it down till here. You can note it down. Please tell me if you have any problem. Please don't hesitate. If you have any problem, you can tell me. You can note it down.
Done, sir.
Okay, Nawal,
Yes, sir. Done.
done. And
Yes.
this thing also you have noted.
Yes.
So now you see we have to convert. Uh, this R1 and R2 in terms of A and theta. This is the problem. Now here, this is the only problem. We have calculated the potential. This is also valid. This is not wrong. Okay, but we will convert this R1 and R2 in terms of theta and A. Okay, so this is the concept of mathematics that I will use here. Okay, so for that purpose, I am drawing another diagram. This is so this is the dipole. And we have a point here. And this is the center of dipole O. This was a point A. This was a point B. This is A. Okay, this is A. And I have drawn it like this. This is a straight line. Okay, this is a point B. This is a straight line. And straight line so that you can understand it easily. Now it's fine. Okay, it is fine.
Yes.
Hmm. Like this. Like this. Okay. So What is this distance? The distance was or R2, and this distance was R1, and this is R. This distance, OP distance is R. OP is equal to R, and this was A, and this was okay, and this angle is theta. Now we have to do the construction. Now we have to do the construction. Okay. So I am doing it with different color. So I am drawing a perpendicular from this line OP at point B, where minus Q charge is placed. Here minus Q charge is placed. Sorry, here plus Q charge placed, and here the charge is minus Q. Okay, you can see in the diagram. You can see in the diagram. I have made this diagram again. Okay, I have made this diagram here again for the construction purpose. So it is easy for you, okay, to understand. So I will make a perpendicular. I will draw a perpendicular like this. I can draw a perpendicular like this. Okay. Okay. So this is a perpendicular. This is a perpendicular. Perpendicular means this line and this line have the angle of 90 degree, and I am representing this point as N. Okay, I am representing this point as N. Any problem, guys?
No, sir.
Fine. This is very important concept. Okay. So why I have drawn the perpendicular? Because I have to calculate the value of R1 and R2 in terms of A and theta. So now what I will do? So this distance will become equal to this distance. Okay, this is the geometry. Okay, so I have drawn the perpendicular so as this distance PV will become equal to PN. Okay, so
Yes.
okay, fine. So PN is equal to, means we can say nearly equal to PV, nearly equal to PV, nearly equal to PV. And what is PV? PV is equal to, Matthew, what is PV?
R1.
Very good, very good. PV is equal to R1. Okay, now from here, can I calculate ON? Can I calculate ON? Why I am calculating ON? You will get it to know soon. ON. ON can be calculated as this OP minus PN. This OP minus PN. Okay. This is like this. This is point O. This is point P, and this is point. And if we want to calculate this distance, okay, if we want to calculate this distance, then we have to subtract OP, this whole line, minus this line, then we will get this distance. Okay, have you understood?
Yes, sir.
Okay, fine. So ON can be written as OP minus PN. Sorry, ON can be written as OP minus PN. Okay. So here this is OP, this is PN. OP, what is the value of OP? I think I have a mistake. What is the value of OP? What is the value of OP? OP is equal to R. So we can write it here R. Okay. One minute. Pn is equal to R1. So this will be Pn. Sorry for that. So now if we want to calculate Pn, then what will we write? OP minus ON. Now it's okay. Now it's okay. Okay. Hello.
Yes, sir.
So
Yes, sir.
we will write. We have to write Pn. We have to write Pn in terms of OP and NO. So this will be OP minus ON or NO. Okay. So what is OP? OP OP is equal to R. Okay, fine. And this is ON. If you miss one thing in the construction, then whole derivation will get in trouble. Okay. So this is the thing. Okay. So now you can see here is the triangle O and B. Here is a triangle O and B. I am drawing this triangle here. And this is the angle theta of this triangle. This point is O and this is P and this is B. This distance is A. OB is A, Matthew?
Yeah.
Okay. Oh, actually, this point, this is not the P, this is N. Okay. This is point N. And this angle is 90 degree. This angle is 90 degree. So if we want to calculate the value of cos theta from this triangle, how we will calculate the value of cos theta? How we will calculate the value of cos theta? What is the cos theta? Cos theta in a triangle? Can anyone tell me? If you don't know,
Base by
yeah,
hypotenuse.
very good. Base divided by hypotenuse. It is hypotenuse. Okay. So here, please remember one thing. Opposite to 90-degree angle, opposite to 90-degree angle, there is always hypotenuse. And with the side with which the angle is making, this will be the base. Okay, fine.
Yes.
So what is base? ON. Here base is ON and hypotenuse is A. Fine, na? So we
Yes.
can write cos theta as ON divided by A. And from here we can calculate the value of ON. What will be the value of ON? Please tell. A cos theta. A cos theta. Okay. So now, what I am going to do, I will writing here Pn equal to R minus ON. So R, now what is ON? A cos theta. Okay. And what is Pn? What is Pn? What is Pn? Pn equal to R1. Fine. We can write
Yes.
Pn equal to Pv and Pv equal to R1. So we can write this expression as R1 equal to R minus cos theta. This is the, now we have calculated the value of R1 in terms of R. Actually, this will be A theta, A cos theta. Okay. This will be A cos theta. This will be A cos theta. Sorry for that. This will be A cos of theta. So please note it down till here. Please note it down. In the next step, we will calculate the value of R2 in terms of A, R, and theta. Okay. Please note it down. And if you have completed the note, then please tell me. If you have any problem, you can ask me. Please ask me. Have you noted down? Matthew, Nawal,
So,
fine. So I am moving forward. So now we will convert this R2 in terms of theta and A and R. Okay. So for that also we have to do a construction. Okay. We have to do a construction. So I am erasing this triangle. If you have any problem, if you if I erase this triangle, do you have any problem, guys?
No, sir.
Have you noted it?
Yes.
yes, sir.
And one thing more, this is a right angle triangle. Okay. Right angle triangle. Right angle triangle I am looking at. So I am erasing this for the further construction. So now what I will do, I will extend this PO, this line PO. Okay, I will extending this line PO like this. Okay. I have extended this line OP, extended this line OP, and now what will I do? Now I will draw a perpendicular from this point A on this extended OP line. Okay. So it is better to draw a perpendicular from here like this. So is it fine, guys? This perpendicular is fine.
Yes.
Yes.
Okay, very good. So this is the perpendicular. And what is the meaning of perpendicular on any line? What is the meaning of perpendicular on any line? This perpendicular will make the 90-degree angle with the line. So same thing is here. This is the line and this is the perpendicular, and this perpendicular is making the 90-degree angle. Okay. And I am considering this point as M. I am considering this point as M. Fine. So, so why I have drawn this perpendicular? I have drawn this perpendicular so the distance PM will approximately equal to distance PA, that is R2. Okay. So here we can write. Here we can write. Can I erase this?
Yes, sir.
Yes.
Okay. If you have any problem, you can ask me anytime. You are most welcome. I need a space. So now we are doing the calculation for R2. So here, here PM will approximately equal to PA. Okay, fine. Because this we have drawn this perpendicular like this, and PA is equal to R2. And how can we write PM? Can we write PM OP plus OM? Please tell me. Please tell me. It is very obvious. It is very obvious. This is point P. This is point O. This is point M. So can I write PM equal to OP plus OM?
Yes.
Fine now. So I can write this as OP, PM as OP plus OM. OM. And this will be equal to R2. Fine. And what is the value of OP? What is the value of OP? Can anyone tell me what is the value of OP? No, Nawal, Matthew. Okay, no problem. OP, this distance, this distance, this distance, this distance. OP. What is OP?
Yes, sir. I said
R.
yeah.
R. Very good, very good. And nothing. I have changed nothing in the derivation. No one can change. Mm. Mathematics is absolute. No one can change. So OP, we can write OP as R plus this is OM, and this will equal to R2. So now we will calculate OM. So this is a triangle. This is a triangle. This is a triangle. And in this triangle, if this angle is theta, this angle will also be theta. Okay. This angle is theta. This angle is also be theta. With the help of symmetry, we can see. So
Yes.
here, okay, fine. Here, if we want to calculate the value of cos theta, how we will calculate cos theta? Base by hypotenuse. What is base? Base, I have told you earlier, OM is the base. OM is the base because this line is making theta angle with this line. OM is the base. Okay. And what is hypotenuse? What is hypotenuse? OA is hypotenuse. Fine. OA is hypotenuse. Please tell me if you have any problem. Please tell
Yes.
me. So we can write it. This will be OM and this will be OA. What is OA? What is OA? OA is A. What is the value of OA? OA is equal to A. Okay. OA is equal to A. So from here we can calculate OM. OM is equal to A cos of theta. Okay. So now we will put the value of this OM here. Okay, so what we will get? R2 equal to OM. What is OM? R2 equal to, I can write this R plus OM. So this will be R plus A cos theta. Is it fine, guys?
Yes, sir.
So now we have also calculated R2 in terms of A, R and cos theta. This. Please don't remember this. Physics is not for learning. It is all about understanding. Okay, it's all about understanding the concept and the mathematics behind it. Okay, fine. So now we will use the value of R1 and R2. Now we will use the value of R1 and R2. So I have to do one thing like this. Am I audible to you clearly, guys?
Yes, sir.
Very good. It is not working. No problem. Oh, fine. We will write the formula. Okay, we will. I am writing this formula. Okay, I am writing this formula below. V equal to K cube 1 upon R1 minus 1 upon R2. Okay, we have written the same thing. K cube 1 upon R1 minus R2. K cube 1 upon R1 minus. What is V here? What is V here? V is the resultant or total potential due to dipole. Fine. So from here we can write the value of R1. The value of R1, I can write the value of R1 as R minus A cos theta. Guys, hello.
Yes,
Are you
sir. Yeah.
comfortable?
Yes, sir.
1 upon what will what I should write here? Please tell me.
R plus A
Plus
cos
A
theta.
cos theta.
Very good, very good. It's very easy. Now, if I will leave the derivation here, you can also do it because you know these things. Okay. So what you will do? So here we will take the LCM. What is the LCM of these two? The multiplication of these two will be the LCM. R minus A cos theta, R plus A cos theta, and this term will multiplied by 1. So we will write R plus A cos theta, and this will be what is the result? Minus R, and if you multiply this term with minus 1, so what will be the result? Minus R and minus minus plus A cos theta. Okay, fine, guys.
Yes, sir.
We are very near to the result. So now let's see. Now let's see. 1 minute. Can I cancel these?
Yes.
And what is this? R minus A cos theta, R plus A cos theta. You have uh, remembered
Pn
the
and
formula A minus B multiplication of A plus B. That will be A square minus B square. Okay. So we can write it like K cube, and here I can write A cos theta plus A cos theta will be 2A cos theta, and in the denominator I can write R square minus A square cos square theta. This is our final result. Okay. Okay, guys.
Yes, sir.
So our final result is, I am writing here the final result, P equal to KQ. But one step, we are one step. We can write it as KQ into 2A into cos theta. We can write now. Okay. What I have done here, I have written Q into 2A. And what is the Q into 2A? I have told you earlier. What is the value of Q into 2A? Anyone? Can anyone tell me?
Potential.
Q into 2A, earlier I
It's
have told
P.
you this. I have told you P. This P was Q into 2A. Okay. I have told you that I will use this. So we will write here Kp. Okay. So the final expression, this is the final expression. Kp cos theta divided by r square minus, sorry, I have written this will be a square cos square theta r square minus a square cos square theta, and this is our final expression for potential due to an electric dipole. Have you understood, guys? And if you have
Yes, sir.
any problem,
Yes, sir.
please ask me. Please ask me, and you can note it down. From where you want to note it down, from here or from here? From here.
No, sir. Down.
You have noted.
Yes,
Yeah,
sir.
the top one down.
You have noted till here.
Yes, sir.
Both of you.
Yes, sir. Down.
Okay. Okay. Very good. Very good. So I am moving forward. So actually, no. Please try to understand the concept of physics. Okay. So it is not about the noting the things and making the notes and all. You can get the notes from the internet also. But the main thing is that the time that I am explaining the concept, you should remember the concept. You should understand and feel the concept. So it will be better. Okay. So this is the expression. So now there is a point that I will use. Uh, do you know about the ideal dipole? Anyone? Ideal dipole. So what is the ideal dipole? Ideal dipole is the distance between the dipole. Actually, the ideal dipole means this A is very, very small. This A is very, very small as compared to R. A is very, very small as compared to R. Have you understood?
Yes, sir.
In case of ideal dipole, A is very, very small as compared to R. So we can say that like A can be in millimeter, okay, and R can be in centimeter. No, it can be in it can also be in millimeter or in some smaller unit of distance. Okay, so in the centimeter. So it means that A is much less than R. I am writing this because uh, these are the proven things. Okay, these are the proven things from the scientists. So I am not writing this thing from my side. Okay, so if A is very greater than, uh, sorry, if R is much greater than A, so can we write, so what will happen? What will happen? Can we write A square? A square will be more smaller. Here A square will be more smaller. Okay, like this, like this. If you, this is 0.1, this is 0.1, this is small. Okay, if you square the 0.1, so what will be the answer? 0.01. So this is more smaller. Similarly,
Yes.
the similar concept I am using here. Similar concept I am using here. So A small is very small, and 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 this expression r square minus a square cos square theta. Actually, a is a square is very small, and if we multiply this cos theta, so this will become very small, very small as compared to r square. So we can neglect it now. Like I am writing here 10 to the power 5 minus 1. So we can write it now approximately 10 to the power 5. Is it fine, guys?
Yes, sir.
This thing is like that. This thing is like that. You can relate the things. You can relate. So I can write this as r square. Why I am writing here the r square? I have given you the reason also, guys.
Yes,
Yes,
sir,
sir.
because a square cos theta is small.
Yeah. Very good, very good. So from for ideal dipole, what will be the value of potential? What will be the value of potential? Potential will be k into p cos theta divided by, what will come here instead of this? Instead of this, what will come
R
here?
square.
R square. Instead of this, I will put here R square. So for the ideal dipole, the potential is this. And you can learn also this formula because you are going to get the questions from this. And very few questions will be from this formula, and more number of questions will be from here. Okay, Nawal?
Yes, sir.
Okay. So you are writing with me. You are noting with me. Okay. You have noted down these things,
Yes, sir.
No,
or
sir.
you?
One sec.
Okay. You can note. You can note. I am waiting. Actually, in physics, uh, if you want to be good in physics, so you need little knowledge of mathematics, and you should always try to understand something, not the remembering the formulas and all that.
Done, sir.
Nabal, completed.
Yes, sir.
Fine. So what is this B? This B is the value of potential at point P. Remember, please. This B, what is B, is the value of potential at point P. So you can also write it as B suffix P. Okay. Here also you can write it as P suffix P, so that you can easily understand. So this has been completed. Now we will move forward. Okay, move forward. So suppose this is charge minus q, and this is charge plus q, and this is separated by some distance, this point O, distance A. This is a dipole now, guys. This is a dipole.
Yes.
Okay, this is dipole. And what if someone says, I want to calculate the potential on the axis of this dipole, somewhere here, and at a distance of r from it. If someone says, you can also say, I want to calculate the value of potential at point P. So with the help, with the help of this formula or this formula, with the help, actually I am considering this as an ideal dipole. Okay, so I am going to use this formula. Okay, fine. So now earlier the point, where is the point? Earlier the point is here. Earlier the point is like this, like this. This makes an angle theta. This makes an angle theta. Okay. Now this point came here. This point came here. So what will be the angle for the point P? Anyone? This angle, suppose suppose there is a thing like this. There is a thing like this, and this is like this. Okay. This is angle theta. If this thing lie down on this plane, this thing lie down on this plane like this, you can imagine. So the angle will, what the angle will become?
0.
Very good, very good, very good. The angle will become 0 degree. So we can easily calculate value point P, Kp cos theta upon r square, and this will be equal to Kp cos theta will be 0 degree. Okay, and this will be r square. What is the value of cos 0? What is the value of cos 0, Nawal? The value of cos 0 is
1.
1. Okay, this is 1. So we can write it as Kp into 1 by r square. So what is the value of potential at point P? Kp divided by r square. This is our next result. Guys, this is our next result. Please remember this. So this is the potential on the axial point, on the axial point of dipole. Fine.
Yes.
Please note it down. So please remember this formula. Kp divided by r square is the formula. Where, remember, where r is the distance from the center. R is the distance from the center of dipole. Fine. So now you can note it down. If you have completed the note, please tell me.
Done, sir.
Matthew,
Yes, sir.
you are noting, or have you noted?
Noted, sir.
Okay, fine. So now I am moving forward. Now, same thing. This is a minus charge Q. This is a plus charge Q. And these charges. This is the center of these charges O, and so distance A. This is the distance A. Suppose if someone says, I want to calculate the value of electric dipole at the perpendicular bisector of this dipole at a distance r from the center. What if? What if of marble? What if we want to calculate the value of electric potential at point P? Okay, fine. So you can relate this with this. Here, now what had happened? What had happened? This was the line. Earlier, this was the angle theta. Now this theta becomes 90 degrees. Nawal and Matthew,
Yes, sir.
Yes, sir, 90.
have this will become 90 degree. So here theta is 90 degree. We can use the formula. We can use this formula. Okay, Vp equal to Kp cos theta by r square. Kp cos theta divided by r square, and Kp cos, what is the angle? 90 degree. What is the angle? 90 degree. Now divided by r square. And what is the value of cos 90? Anyone?
Zero.
Very good, very good. 0. Very good. So we can write Vp as Kp cos 90 is 0, and this whole term will become 0, and this will be r square. So this will be 0 now. This will be 0. So this is our next result. This is our next result. Okay. And
Yes.
what we say, this is the potential at the equatorial position, or we can also say that perpendicular bisector. Okay, what is the meaning of perpendicular bisector? Bisector of dipole. Perpendicular bisector means this is a line,
It cuts it
this is
in
a
half
line.
and 90 degree.
Oh, okay, no, this is a line. This is half truth. This is a line. If I am drawing a perpendicular bisector, this will divide this line in L by 2 and L by 2, and this angle also become 90. This is the meaning of perpendicular bisector. Okay, this is perpendicular bisector. Fine. So
Yes.
please note it down. Case second. Oh, actually, this is a case second. If you have any problem, you can ask me. This is nothing, but we have derived the things you have seen. Firstly, I have derived the thing, the potential uh, for an angle theta, and after that, after the so much of our calculation, we have calculated the potential uh, for the ideal dipole, and after that we have calculated the potential on the axial position. Axial position means on the axis, on the line of dipole. This is the line of dipole. Okay, this is the line of dipole, and after that we have calculated the potential at point P. At point P, this point P was at a distance perpendicular bisector from this dipole. Okay, fine.
Yes.
So have you noted down these two cases also?
Yes.
Very good, very good. Now we will move towards a question. We will move towards a question. So before the question, we should remember the formulas. Potential on the axial position पे कितना, at axial position, what is the formula? Kp by r square. Okay, Kp divided by r square, and V at perpendicular bisector equal to 0. So we can also write this as V perpendicular, and I can also write this as V axial. Any problem, guys? I am
No, sir.
writing it for solving the question, so it is easy to remember. V axial equal to Kp by r square and V perpendicular equal to 0. Okay, so now I am writing one question. We will use these formulas. So this is the question. Two charges. Now we have understood the formulas. Now we have to apply the thing. In life also, we know a lots of things. When it comes to apply to the things, we fail. Maybe so. Always try to find the application. Okay. So two charges minus q and plus q are placed at the coordinates are given 0 comma 0 comma minus 3, 0 comma 0 comma minus, and another charge is placed at 0 comma 0 comma a. Okay, now question says calculate number one, potential at point A. Potential at point A. Second, potential at point B. Okay, and uh, and the coordinate of point A is given as 0 comma 0 comma some z. Okay, and the coordinate of point B given as A comma 0 comma 0. Okay, this is fine.
Yes, sir.
Okay, so and the coordinate of C also given, C 0 A and 0, and third part is the last question of this lecture. Work done in carrying proton from A to C. Work done in carrying a proton from A to C. I think this question has some problem, but we will try to solve it. So now this is y-axis, this is x-axis, and this is z-axis. Okay, and these axes are mutually perpendicular to each other. These axes are mutually perpendicular to each other. So we have given where the charge is placed, -q is charge placed at 0, 0, minus a. So we will use different pen color. So here -q charge is placed, and the coordinate of this is 0, 0, minus a. Okay, 0, 0, minus a. Why I am writing this 0, 0, minus a on z-axis? Because hello,
X
Yes.
value
because
and Y value is 0.
because the x and y coordinate of this point is 0, so this point will lie on z-axis. In the same way, we can write another point 0, 0, a, the position of this charge, sorry, this plus q charge. Okay, so what is this distance? The distance will be a, and this distance will a. Okay, so guys, this is the location of, we have located these two charges. Now we will calculate the potential at 0, 0, z, 0, 0, z. So 0, 0, z will also lie on the on z-axis. This is the last question. I am extending this z-axis. Okay, so suppose this point is here. So this is a point A, the point A, and having the coordinate 0, 0, z. So what is the distance between this point A and this origin? O is the origin. OA. What is OA? OA will
Z.
equal to Z. Z. Very good. And this is also the center of this dipole. No, oh, sorry. This O and this point, this I am supposing this as P, where the charge Q is placed. I am supposing the point P, and this is Q. Okay, guys,
Okay.
it's fine. It's fine.
Yes.
So the distance between the point A and the center, what is the center of dipole? This is the center of dipole. This point O is the center of dipole, no? Center of dipole. This is the dipole. This is A, and this is A, and this point Z is the distance from the center of dipole. So we have a formula. We have a formula for calculating the potential, and this point is also lies on the axis of dipole. On the axis of dipole, what formula will we use? What formula will we use? We will use this formula: p axis, v axial, kp by r square, kp by r square. Okay, so k, what is p? Please tell me what is p? Q into 2a, and divided by, what is the, what is this distance r? What is r here? This is r.
Z.
This is the last question. So our answer is this. Okay, this is our answer. P equal to k q into 2a by z square. First part is completed. First part is completed. Now we will calculate the value of potential at point B. Fine. We will calculate the value of potential at point B. So point P, a comma 0 comma 0. And remember, the point A will lie on the x-axis. Will lie on the x-axis because other coordinates of this point P is 0. Okay, so this point is lying on x-axis, and this is our dipole. This is our dipole, and this axis and this axis is perpendicular. This axis and this axis is perpendicular, means the point B lies on the equatorial position. Okay. Second, point B at perpendicular bisector. So what will be the potential at point B? It will be equal to 0.
Yes.
Fine. Okay. So please remove one thing. Please remove one thing from the question. This point C. Remove this. We have a time issue. So please remove the point C from the question. So now I will do the third part. I will do the third part. For the third part, what is the third part? We have to calculate the work done in carrying a proton from A to C. From this point A to the point B. Please correct it. This is not a point C. This is a point B. This is a point B. Okay, fine. Okay. So we are at the end of our lecture. So what is the formula of work done? What is the formula of work done when we will move from A to B? How can we calculate? Work done can be calculated as charge into potential difference. Okay, VB minus VA. Same thing. We will calculate the work done like this. Okay, have you understood, guys?
Yes, sir.
This here the potential is VA, here the potential is VB. So we can calculate the work done in carrying a proton. Proton means charge. Proton is having a charge. So what is the charge of proton? B is written as E. And what is the potential at point B?
0.
What is 0? 0 na?
Yeah.
0. And what is the potential at point A? This is the potential at point
KQ
A.
into 2A by Z square.
Very good. This will be K Q into 2A divided by Z square. Fine. So from here we can calculate the work. Work will be minus E K Q into 2A divided by Z square. Okay, fine, guys. And this is our answer of this last part. Sorry. I have to write it again. Please wait for a minute. So this will be work minus E K Q into 2A divided by Z square, and I am highlighting it with the green color, so answer is visible to you. This is the work. Fine.
Yes, sir.
What is the okay now? So from here, one thing we can also, I am just going to finish the class, but just last thing I want to tell you. So have you noticed this work done does not depend on the distance between them, because this in this formula we have only calculated the potential. Here is only potential. Okay. Okay. So have you noted down?
Yes, sir.
You have noted down the solution also?
Yes.
Okay, fine. So guys, this is all about today. And uh, if you have any problem, you can ask me now. Anyone, please? Nawal, Matthew?
No problem, sir.
No problem. Okay, fine. Very good. So this is the thing. So now you can leave the meeting, and thank you for joining. And
Thank you, sir.
I have
Have a
I have
nice day.
I have tried. Okay, thank you.